Good morning everyone. Today we are going to do the practical of finding acceleration due to gravity using simple pendulum. This is the apparatus of simple pendulum, children. This is called clamp stand. What is this called?
Clamp stand.
This is the thread. Can you all see?
Yes, ma'am.
And this little spherical ball is called bob. What is this called?
Bob.
And one more thing we need in this experiment, that is stopwatch. Children, this is stopwatch. You will all find on your tables, right? How does it work? There is a handle here on the side. When you move it, you will find it start moving. Is it moving? Now see, is it moving?
Yes, ma'am.
So this pendulum bob, this stopwatch moves. I have to calculate time from this stopwatch. Otherwise, you all have mobiles with you. आपके मोबाइल में वॉच होती है आजकल, उसमें क्लॉक भी होता है, स्टॉपवॉच भी होता है. आप वहां से you all can see the time. Now what we have to do is, first of all, you should all hang. This is where you can move it. You all have to first of all measure the length. That length of the hanging thread should be 1 meter. For that you have a scale. This is meter scale, children, and you will get this kind of thread. आप सबसे पहले इसे 1 to 100 ऐसे measure कर लेंगे. कुछ extra length लेंगे beginning में. Why? I need a little length to tie this thread. Okay? And once you tie it, the hanging thread should be 1 meter long. Am I clear to everyone? Check. That's it, how to hang it, and hanging you will do. You are more expert than me. Now, try to make bob stationary first of all, so that it only moves linearly. It should not have a rotational type of motion. First of all, let me tell you what should not be there. Okay? See that. I'll bring it here. And look at my movement. I hope it is captured in the video also. It should not be like this. See. No. Can you see the bob having a rotational motion also?
Yes.
No. Bob should never have a rotational motion. It will only have linear motion. Now I'll show what is linear motion. For that, keep the bob in your hand for some seconds, so that rotational effect goes. Now try to sit as per the position of the bob. If you stand at a height and position is at bottom, then the rotational motion will come, right? So what do? You stand here or sit here like this. Keep the bob in your hand and then leave it so that it can move and go that way. Right? Even keep it more in your hand so that it should only go front, back. Going straight, back. Can you see now the bob is not moving in rotational motion?
Yes.
Can you all see it?
Yes.
It is only having a linear motion. What else should not be there? Once you leave the thread, never do it like this. Stand parallel to it. If I stand here and leave it like this, it will go and touch the table. This is wrong. Right? Such type of movement should be avoided. Up. What should not be there? Suppose I have to count it. I have to count for 20 oscillations. What children do generally? Suppose, count with me what is counting. Okay, I'll tell you. The position from where I leave the bob is called extreme position. This position at center is called mean position. Position at the other end is called extreme position. Now motion, once the bob starts from here, goes to second extreme and come back to first extreme, is called one oscillation. First of all, I'll count 1, 2, 3. Then you add your voice to me to count 4, 5, 6, 7, 8. And do not sing 1. Please. Once it stops at a point, say 1. Okay? Like me. 1, 2, 3, I will speak. You see the motion? Pavneet Singh, can you see it, or I should shift your position? Very good. Chaliye. हाँ जी. हाँ, please. To all those who the experiment is not properly visible, you can change your position silently. Come here. displacement from where I started, give me the scale. The displacement from where I started, Jasran, give me chalk. I always ask children to make boundaries in advance. Like 40 centimeter here and 40 centimeter there. Do not change on the experiment. Suppose I take it 50 centimeter. Mark 50 centimeter this side, 50 centimeter this side, so that I can have an even type of movement. Now I take my bob to this 50 centimeter pole. Are you getting my point? Are you all understanding? All these are basically precautions I am telling you. All these precautions and sources of error I should take. More sources of error I will add on C. 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11.
This is how to count. Here, how to count the number of oscillations. What is number of oscillation? How many times it is coming back from the same extreme position I have left it. Then, second is now you have to find the time also. Now you all keep your stopwatches or watches in your mobile or watches on your wrist ready to find the time. Yes?
एनर्जी लूज की वजह से टाइम पीरियड चेंज नहीं होगा?
नहीं, that all will count definitely in all. That is why we take always mean. क्योंकि कुछ वैसे तो हम क्या कर रहे हैं? We are trying to avoid the dissipative forces. What else I was trying to tell you? What else should not be there? Suppose fan is not moving. क्योंकि अब तो सर्दियों में मैंने कई बार I start this experiment in September, October, fans are there. If fan is not moving in the lab when you started working, it should not move during the exam. Because air, wind produced, pressure produced by fan air can also affect the motion. You should not do it, right? The windows and doors which are closed at the beginning of the experiment should not be opened or closed during the experiment. We try to keep the temperature, pressure, movement all same. Are you getting me?
Yes.
These are basically sources of error and precautions we should take while doing the experiment. Are you all getting me? Yes. Now I start the experiment. What I have to do? Now we'll count 20 oscillation and see the time, and I will tell you what I am doing. Shall I start? You all help me now. What is the experiment? So here I go. 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
and tell me the time.
40 seconds.
42 seconds.
40
Okay, never mind. I take 5 readings like this, you will take 5 readings later. So I have taken 20 oscillations. Suppose first time 42 seconds. One child said 40.
41.
What other? 41. Suppose sometimes again 42 or sometimes 31. I have taken the average. Somebody said 42, Ashwin said 40, you people said 41. So let the readings are like this. If the readings are like this, but you have to take all the 5 times. Okay, I will repeat the experiment 5 times. Now what is time period? 42 divided by 20. What is it? 2.1. 40 divided by 20.
2.
Divided by 41. Karo?
2.1.
Am I right?
Yes.
Chalo. Now what is mean of this? Add them 2.12, 2.05, this divided by 5. Suppose it comes out to be 2 seconds. Right? Then acceleration due to gravity is 4 pi square L by T square. If I put the values in this, what will I get? G is equal to 4 pi square L by T square. 4 is 4, pi is 3.14 ka square, L is 1 meter, time was T square 4, this will cancel out, this comes out to be 9.8 meter per second square, right? So the value of G comes out to be 9.8 meter per second square, what we wanted to do. Am I clear about the experiment?
Yes.
Stop the question.